Hey guys, Mr. Gagnon here. I found that these videos are best played at 1.25 speed. It just seems like it gets you get through the material a little bit quicker, and also I tend to talk a little bit slower when reading the notes. So that being said, let's talk a little bit about the second physics unit we'll be looking at. Okay, and I'm going to take the notes and I'm going to boil them down into a series of videos for you. Because sometimes just looking at the notes is not quite enough for some people. So I figure I'd get it to you two different ways. So in your notebooks, if you want to write down these notes here, I'm going to get you a picture, and I just want you just to have it's just a thought experiment. Okay. So if I have a ramp like this, and then it goes back up. Okay, and I'm going to draw like a dotted line here. Okay, if I like were to take a ball and just drop it down the ramp, okay, you guys know the ball would travel down, and then just by intuition alone and being able to understand basic physics, you'd say, well, yeah, the ball would go down, and it would roll up to a certain height, and then roll back down, and then roll up, and then down, and then up, and then down. And each time it did it, it would actually wouldn't go up as high, and eventually it ended up like right in the center here. Okay, now what I want you guys to do is visualize, if you could, a ramp that's perfectly smooth, zero friction. Okay, no friction at all, no air friction, no surface friction. What would happen to the ball if I let go of the ball on this ramp? Think about it for a second. Okay, so what would actually happen is if I took away all of the other forces acting on the ball would go down the ramp, and it would actually go up to this point, okay, exact same level, and then come back down and come back to this same level, and up to this level, and back to this level, and back to this level. It would actually do that for a term that I don't really like to use that often, but it would do it forever. It would actually do it for infinity time, okay, which is kind of a weird concept. And this is a concept that I kind of like to get into a little bit if I was in front of you guys, because at this point I usually get a lot of questions. What is infinity? How do we know what infinity is? Well, the deal is that, and I'll just give you a quick analogy here. So the human brain is only able to process and understand so much, and to understand the concept of infinity would be kind of like a mouse trying to understand the concept of getting in a car and driving to the gas station and pumping gas. We know the mouse's brain capacity is not, can't understand that concept. Nevertheless, even try to do it. So humans, yeah, we actually do have limitations. Okay, and one of those limitations is to not really being able to understand the concept of infinity. So what this leads to is the understanding that if I take away all the external forces on the ball will go forever. All right, so that means that there are external forces in the ball to make it slow down. So here's the second part of the thought experiment. If I were to take that ramp and extend it out a little further, and I drop the ball and let it go, where would the ball end up? Okay, it actually would end up right exactly at the same height as the other side. It would roll down, come up here, and then roll down, come up here. And that is if I took away all of the external forces. And here's the other thought experiment. We've got three of them. So if I let this ball go down the ramp and it went horizontally, okay, what would happen to the ball? again, I'm getting rid of all the friction, and just considering that the ball has no external forces on it. The answer is that the ball, if allowed to, would actually continue to roll forever. Okay, again, that's again a foreign term to our brains. We don't really understand the concept of forever because we only understand concepts in terms of beginnings and ends. But in the world of physics, this ball would roll forever. And if you've ever watched The Sandlot, a little kid there that is trying to get away from the big dog says, "Forever." Okay, it's a good movie to watch if you're on Netflix and you want to get onto a good movie. So there was constant debate between Galileo and Aristotle about these forces. So I'd like you to draw the picture of a simple object. Okay, here's a box. Okay, the box, we'll say, is sitting on a surface like that. Okay, if I pull on the box with a string, okay, I can say that I apply a force to the box. Now, in real life, in real life, we know that if we pull on a box, it's going to actually pull back at us a little bit. And this backwards force, or this opposing force, is a force called, you got it, friction. Okay, so in this situation, if I pull on the box forward, friction pulls it backwards. So let's, if you think back to that thought experiment, okay, we're going to come up with a set of laws to describe motion. And you may have learned these back in the 7th grade, but we're going to get into more detail. Okay, let me first tell you the story about Isaac Newton. All right, this was a scientist. He lived in the 1600s, and he was sitting next to an apple tree one day, and he was thinking about a lot of things, and he looked up at the moon, and he saw and understood finally for the first time that the moon, like, why is it just staying there? Like, why is the moon not falling to the earth? So he said, well, actually, it is falling to the earth. It wants to fall to the earth, but it's going so fast in a circular path that it doesn't actually physically fall to the earth. It doesn't ever contact the earth. So at that moment, an apple fell off the apple tree and smacked him in the head. And it's said to have knocked something into him for him to understand gravity. Now, the cool thing is that later I'm going to tell you another story about Newton and about how the apple is about the weight of 1 Newton. And we'll talk about that later. But what I want to do is just introduce to you guys in this next 1 minute or so Newton's first law. Okay, Newton's first law. Okay, what he said was that, and I'll write it down for you, objects tend to stay at rest or motion unless acted on by an external force. Okay, so in other words, an object maintains its velocity unless acted upon by a non-zero net force. So, an example of that is that I used to have a cat, and this cat was a very, very large cat. And to get this cat to move was ridiculously hard. The cat liked to stay at rest, unless acted on by an external force. I'm gonna stop there because the video is at 10 minutes, and we're gonna chunk this out into 10-minute video sections. All right, so we'll see you on the next video.